Priyanka, Priyanka,
Dr. Priyanka and Tanya, can we start now?
Sir, I think the given time was 9:15.
Okay.
Yeah.
Dr. Himabindu?
Yes, Priyanka, I'm here.
Okay, I think you can start around 9:10. You can start introducing the speaker because 9:15 is the time according to the schedule.
Yeah, yeah. Whenever you say go ahead, I can. Thank you.
Okay. I guess you can go ahead.
Okay, a very good morning, everyone. We had a successful session yesterday. The first day was really, very beautiful with a great lineup of speakers. And today also on the second day of this conference, we are going to have another great lineup. To start the second day of conference with, we have Dr. Debjani Ghatak. A few words about her work. Dr. Debjani Ghatak is a physical geographer with a specialization in climate science. Her research includes, but is not limited to, Arctic climate, variability in snow cover, high elevation warming, and climatic issues of India. She uses a combination of empirical analysis using statistical methods and physics-based model simulations to examine the physical processes. She has collaborated in the past with NASA applied science teams and has worked at Roger and John Hopkins University. Currently, she is engaged in diversity, equity, and inclusion projects as a mentor. She is heavily involved in undergraduate teaching at Texas A&M University and uses various pedagogical methods in classroom setting to maximize student engagement. Dr. Debjani Ghatak, we welcome you and the floor is open to you. Thank you.
Hi, everybody. Good morning. Can you all hear me clearly?
Yes.
Okay. Let me share my screen and please let me know if you can actually see the screen as well.
Yes, we can see the screen, but you have to make it into full screen.
Okay, okay. Give me 1 second. Maybe I'll just. Okay, can you all see the full screen mode?
Yes, very much.
Okay, awesome.
Thank you.
Okay, so first of all, thank you so much. I think this is really a great platform and great opportunity for all. I mean, you guys have a great speaker. So I was actually saying a few minutes back because of the time difference. Even if I want, I couldn't attend the other talks which happened yesterday, but I'm looking forward to see and hear the Zoom recordings. But thank you again, and I'll not take much time. I'll try to make it like within 30 minutes talk, but please stop me at any point if you have any question, or you can also ask me question at the very end. So first of all, my talk today, just wanted to kind of talk about something that I have worked in the past, and I also wanted to kind of talk about stuff that more relevant with the theme of this conference. So there are two keywords that I want to kind of focus here. That's heat wave and deforestation that I want to talk about today. But I actually changed a little bit of my talk and I added one extra component that we are all kind of facing right now, warming climate change signal over Himalayas. So I would also expand that as well. So just a little bit about me, that I am I am actually a climate scientist, but I actually like to observe nature, and I like to watch cloud. That's kind of my really kind of a thing. I kind of, when I was a grad student, I used to keep a logbook, kind of like writing that what kind of cloud is there in the sky. So it's kind of a fun stuff about me. I also love to teach. So I feel like nowadays that as a scientist, I think our responsibility to the society is not just doing science, but to kind of spread it through our students. The kind of the message to the more society where people do not know about what's going on surrounding us, and teaching is a way to do that. Besides that, I'm kind of really grateful to my teacher friends and families to support me always in my work. So the first topic, like I mentioned, which was not in my title, that is the high latitude warming. So let's focus a little bit on this graphic here in this figure. And this is actually a model, how a model looks at a high latitude region. So when we look at a map of Himalayas, we see a lot more variability there, but model, it has its own limitation. So what I want to point out in this graphic, that you see like a shades of brown that actually does not go beyond, let's say somewhere 5,400 meter and above. So model actually cannot simulate very well the high latitude, high altitude processes, as well as actually high latitude processes as well, but here the high altitude processes. So I will kind of try to use a pointer to explain few things. So I hope you can see my pointer here. So this brown shade region is actually the region of the, not just the Himalayas, but you're looking at the Tibetan Plateau, Karakoram, Central Asia. All the green below this, south of the brown areas, is actually great, the Gangetic Plains. So we see the geographical region where we see very high elevation, but also we see the plain lands, right? So the color here, that's why the color code shows anything 0 and goes to 7,000 meter and more. So if I choose this region from a model, and the model that actually I have chosen for this study is known as CCSM4, which participated in the International Panel in Climate Change Report. So the results in my few following slides will be based on only this model. Now, again, I want to mention that model is any model that participated in IPCC could not resolve the high altitude feedback very well. So the focus of here in the study is to kind of look at what is the climate change signal that we see in this Himalayan region, and what if we see any high latitude warming or not, and if so, what is the correlation with the snow, kind of more like a snow albedo feedback in that region. This is not really a very complicated graph, but I'll just try to kind of explain it here a little bit with the help of this pointer. So this graph, in the kind of the x-axis, you see there are 12 months of the year, and you see in the y-axis that's a percentage change in the surface albedo. Now, when we think about Himalayas, we think about, okay, the Himalaya has a range of elevation, and we know there is a kind of the few low ranges, let's say below 2,000 meter, and then there's like, kind of the mid ranges, and then there's a very high elevation ranges that's kind of basically 4,000, 5,000 meter and above. Now, snow line, or the snow in general over Himalaya, also kind of varies that elevation band, because in the low elevation, we hardly sometimes get any snow because it's just warm, or when the precipitation falls, it falls probably as just a rain. But when you go to high elevation, we actually have more snow. So that's a general like physical process. But how it is important? It is important because when think about like when a climate change world, when we are having a warming, that snow line will actually recede back. That means right now where you see snow, you will not see the snow like in probably after next 20 years, because that snow line will go to the more higher elevation. And as a result, what will happen is that will cause the changes in the snow reflectivity process. And as a result, the albedo, surface albedo, will also change. So in summary, from this slide is how that albedo change will generally is happening in this model at different elevation band. So I will just point out a few things. Instead of going to all this different elevation band, I'll just point out only, let's say, the springtime, which is March and April, and basically like after February, that things start changing, and you can see a lot of changes is happening where I'm moving my pointer. So all those lines are kind of changing, and that actually basically shows that how different elevation the albedo is changing in that season. Now, why spring is important? What do you kind of think in our life that what happens in spring? So in spring, in the winter, we expect there will be snow in the Himalayas, and in the spring, that snow water will melt, and that will be very useful for our agriculture purposes, and it will kind of feed our rivers, right? So if we have more warming in the Himalayas, that means it will probably will not see as much as snow, and as a result, our melting, like the source of the melt water will also decrease. And another thing that will actually cause this change and cause this feedback loop is the albedo. And here comes the importance of the albedo, because if you have less snow, you will have less albedo, and that will cause more warming, and then it will have more less snow. So it kind of goes into this positive ice albedo feedback. And what model basically is suggesting in this graph is that our high elevation regions, like the regions like 3,000 meter or 4,000 meter, is the region where we are looking at a lot of changes are already happening, and that is reflected in that the reflectivity of snow. So albedo is also decreasing. Now I'm going to point out only one more thing before I go to my next slide, is the month of December. Now, December is a very where my pointer is right now. And if you see all the 5 line graphs here on the December, you see, and if you match it with the color code, you will see that 4,000 meter line is actually showing very negative values. And that means that that is a region where we're having a lot of changes in albedo. So that means it's a kind of a climate change signal, and it's a kind of a scary signal. That means our higher elevation regions up in the Himalayas is actually seeing climate change, means a more warming, and that is causing less albedo. Now, I'm going to now go to the next slide to show you this, look at this correlation a little bit more at a more futures time scale, that how this model is predicting is going to change this association between the changes in surface air temperature and albedo and the snow cover. Now, in order to show this relationship, I actually chose not all the elevation band from my last figure, which makes the picture very complicated, but I just chose this 2 graph where the top one is only 3,000 to 4,000 meter, and the bottom one is 4,000 meter and above. Now, the take-home message basically from this is, if you just look at this two graph, you will see that there is a kind of a downward trend in the both line graph. And there are three graphs in the two plots. The one which is blue is the snow cover, the red is albedo, and the black is surface air temperature. And it is suggesting that snow cover is decreasing over this century. As a result, albedo is actually decreasing. And this is associated with the kind of the increasing surface air temperature over this region. Now, the downward trend in the surface air temperature does not mean the temperature is actually decreasing. It actually is showing that over this region, how the average temperature is actually changing over this whole region. So in summary, what this study actually suggested is that the CCSM4 model that participated and is one of the main model in the Ipcc report suggested that our Himalayan region is actually looking only, not just the Himalayan is only the Himalaya Tibetan plateau and the Central Asian region is actually showing a climate change signal where we are having a decreasing snow, and that is causing this ice albedo feedback. But I also wanted to give one another message that we also kind of find out, and which is very interesting, that the Karakoram region, which we kind of also kind of like, we can also say Karakoram as a western part of the Tibetan plateau, actually shows a little bit more snow. So climate change, it can be, confusing, because some people can say, oh yeah, Karakoram is having more snow. That means probably the global warming is not happening. And there's always a debate about the climate denials and the people who are doing this climate change research, right? So the climate change signal is not always very clear cut, and it can actually cause a lot of extremities in a different indicator. Like some places can have more rain or some places can have more snow, depends on what the atmospheric temperature is. So this is also in the scientific community, this is also known as Karakoram anomaly, that when the whole Himalaya is facing increased temperature and loss of snow, Karakoram may actually see more snow. Okay, so I hope I did not lose all of you, because I know it's a little bit very broad topic, but I'm trying to kind of summarize what all this different research is showing. But I'm going to actually move from a lot of talking about snow to heat wave. And right now I know India is facing very extreme high temperatures. And so my next few slides, I'll be kind of talking about only the heat wave. So the few things that about the heat wave, like in 2015, when I was doing this research, there are a lot of headlines were coming, and these are few the snapshots of those kind of the reporting from different media outlets like Telegraph, CNN, and other online media outlets, where I was kind of looking at that India is facing this heat wave. Now, as I'm interested in snow, and the snow is big part of the hydrology, so another things comes in the hydrology is also the rain, right? And heat wave, which it basically leads to the drought in India. And it's kind of like for us, when we do science, sometimes it does not affect us that much, but it affects agriculture, it affects a farmer much more, and their life actually depends on it. So this is it's not just fun talking about it, it actually has a more greater economic impact on their life. So when I was looking at all those reports, and I was kind of like interested in doing some research on it, so I kind of like looked at a little bit of history of the heat wave and how that may actually change in future. So what I'm going to summarize here, that what happened in the past and what going to happen in future in the heat wave scenario. So few years, probably you see in my slide that this are the years 1998 to 2003, 2005, 2015, 16, and actually part of 17, we have seen a lot of extreme temperatures. Now, high temperatures in the month of May is not very uncommon in India. We know we are a tropical country. We know, like, temperature can go up to 35, 38 degrees Celsius, and it's a hot month. It's not a big deal. But what big deal is when the temperature extremes are becoming more frequent and is becoming more intense, and that cause this kind of drought and affects our hydrology. So now I'm going to moving to kind of little bit to our outlook, not just India, but let's just broaden our view and what's going on in the whole world. So these changes in the heat wave scenario, we have seen there are big heat waves actually happened in recent history in Europe and in Russia, and in 2003 and 2010. Now, when generally this happened, what actually happens from a more scientific point of view is that we, in a summer month, we have a lot of we have a lot of short wave radiation comes from the sun. So we actually get a lot of solar radiation, and that heats up our Earth's surface, and that causes basically less soil moisture, so our soil becomes very dry, so we lose soil moisture, we lose our water storage, and that actually enhance the sensible heat flux from the surface. So from a more scientific point of view, what we see that there is an interaction happen with the surface and atmosphere, and that is part of the reason that sometimes we see this extreme temperature. But the main there are key players that in India, kind of from a more Indian perspective, that we know the monsoon plays a big role. Sometimes if the monsoon is delayed, we know that it's gonna affect our more extreme heat wave is gonna happen, and sometimes the monsoon can actually, the pre-monsoon can also be inadequate. So the timing of the monsoon is very important. Another important thing that came out in the literatures a lot is not just what's happening in India, but what is happening in our neighboring region, for example, in Pakistan. So that is a condition that actually affects our hydroclimate situation as well. Now, the last bullet point in my slide is a super important, that is a connection to the large scale atmospheric circulation. So that is primarily the reason why a couple of the big heat waves that happened in the past, that actually happened because of its the changes in the circulation in some other parts of the world, but that actually affects our atmospheric condition. So I'm going to just to kind of wrap our head around not many heat waves, because it becomes a little bit more difficult to dig deeper. But if we just focus in one heat wave, and I chose the year 2015. Now, 2015 made big headlines in the media because it was a little expensive for us. And if this is a map from Wikipedia, and if you see Delhi, Allahabad, Jharsuguda, Hyderabad, so it's like all over the country, starting from north to east to south, our heat wave was kind of spread all over the country. So that heat wave actually, I kind of did a little research on the heat wave, and I found something very interesting fact, which sometimes we don't see in the media news, and that's our job as a scientist to kind of dig those information to understand the scientific processes. So it's not just a drought, but it actually 2015 heat wave actually was costly because it took a lot of lives. And this is kind of a database, the number of deaths that happened. And Andhra Pradesh was really the topper here. And if you notice one thing in this table that the reason that I just wanted to share this is the timing. So it happened in June, couple of the states, Andhra Pradesh, Telangana, Odisha, and the other states, actually it happened in the end of the May. So that means when this heat wave struck India, it did not happen in a same time. It happened actually in kind of a I would say it's like it had a kind of a two peak. So this the result that I'm going to show you is from this paper, because just for the time, in the limitation of the time, I'll not be able to go over everything. So if you're interested, you can just take a look at more scientific details later from this paper. But what the kind of the key points that I'm trying to make here is, what is the spatial signature of the heat wave in 2015? When did it strike India? And what's the role of this local feedback that triggered this heat wave? So in order to understand that, I kind of like looked at this kind of a moving window between April to June, and broke it down into like kind of a more like a weekly time slot, not exactly weekly, but kind of a like a kind of a like a rolling window. But what it kind of came out here, and this map is basically showing the temperature anomaly, which kind of colored here as a very dark red color. And I'm going to point out with my pointer here this particular map in number D, which is the very end of the May. And you see this is like a red splotch that runs from eastern part of the India to southern part. That's really the kind of the first point when the heat wave struck India. And this is all those later actually the main kind of the towns which are affected very much by this heat wave. But then this heat wave kind of died down for a few days, and then I'm going to now go to the very last map, which is the bottom right corner where my pointer is, and it kind of came back again in June, and it kind of shifted to the North India from south, and basically UP, Bihar, and those regions where this time were affected more. So in summary, what my findings are here is that this heat wave actually had this two peak, and it is interesting that those two peaks actually had completely different reasons of their kind of the outbreak. So the first time when it actually hit the South India and the eastern part of the India, the cause is actually discussed from a different paper, and I'm not going to actually go to all the scientific detail, but basically it is connected to the changes in atmospheric circulation at some other place, and that drove this kind of changes in the circulation over India and caused the heat wave. But the second time when it happened over India, and this slide is actually showing that second peak over UP and Bihar, those regions, this actually is not associated with the changes in atmospheric circulation, but it actually happened because of the local surface and atmosphere interaction. And in summary, what actually happened at the beginning of the June is that our soil was very dry, and we got a very cloudless sky, and lot of incoming solar radiation, means lot of sunlight that makes our surface more dry and more hot, and that causes this heat flux from the surface to the atmosphere. And so our atmosphere is kind of heated from a bottom-up approach. So it's like our surface heated our atmosphere, and it caused this heat wave over this huge region. So this actually has a more implication, more like a land surface management or policy point of view, because we can actually a lot of times we actually when we make a lot of economic and social policies, we have to kind of take care of this land surface management to reduce such an outbreak of heat wave in India, where when we are so prone and vulnerable to this kind of climate extremes. So my kind of like take home message from this this small study and the paper is, of course, we cannot control the changes in atmospheric circulation that is happening somewhere else, or probably the changes in El Nino, things like that. But we can sometimes can control the things through different social and economic policies, and that can actually reduce these economic damages, or it will not take lives like it happened in 2015, that we lost so many lives. So now, as this actually particular conference has a future implication, I just thought to also bring here a very important study, which is of course not done by me, but this is a paper that if you're interested, you can look at it. It's a paper by Murari et al., where they actually looked at how this heat wave will be kind of changed in from this climate model projections in the coming years. And their kind of the take home message here is that which is not a very happy message, but our heat waves are actually projected to be more intense. It will have a longer duration, and it will basically occur more frequently in the coming year. So I guess the only thing we can do to minimize the impact on the economy and the lives is to kind of take proper adaptation and mitigation strategies to at least minimize the impact of the heat waves. Okay, so now I will kind of go to, I don't know how I'm doing with the time. I'm sorry, I just left my phone somewhere. But
that's okay. You have enough time. We can continue.
Okay. So this is the last part of my talk. That's the deforestation and disease outbreak. Okay. Oops. Sorry. Yeah, so I actually first of all apologize for not sharing any results from this talk more, because I'm actually working on a paper which is not published with a friend of mine and a colleague from India. So just to kind of keep that confidential, I'll just talk about just kind of what we have found here, because I thought it's very interesting and important. But I just kind of try to explain this more orally, not through more scientific graph here. So this story of deforestation, and I'm moving more from hydrology to land surface or a land use land cover change topic here. So I'm kind of switching a little bit direction here. And what we see here is the map of India on my left. And you probably already noticed that, let me see my pointer, which disappeared here, that Kerala has been actually highlighted. So that's Kerala, and this red point in the Kerala is a district called Wanad. Wanad is a kind of like a lot of tourists go to Wanad because it's very pretty. It has mountain, it has forest, and it's very beautiful. It has this tropical forest, and it has little bit high elevation, not as high, of course, as Himalayas, but of course, it's part of the Western Ghats, right? So now, if you look at the right-hand side, which is more zoom in look of Wanad district, and Wanad is actually a heavily forested region. And I want to give you a little bit history here. So when under the British rule, British actually discovered that this place is very good for plantation. So they started plantation there. they took over this land from the king that time, and they started this, and there start the journey of deforestation. Since then, we continue cutting the forest and changing the landscape. Now, we all know what deforestation is, right? We all know that, cutting the forest, changing the forest is a forest degradation and deforestation. But here, the story is a little different. And the story is that we are changing and cutting the forest, and we are converting this forest into plantation. What kind of plantation we do here? We do coffee, tea, teak plantations, eucalyptus, and all this thing. And those, if you look at a picture of eucalyptus or teak plantations, and if you just put a picture of a forest side by side, you will probably, if you ask someone, they will say, oh, that looks like a forest, right? But that's not a forest, that's a plantation. And when we make a plantation, we actually change the whole landscape, because we lose biodiversity that forest used to serve as a home of many species of plants. It used to serve as a habitat of many species of animals. So Wana is no such exception. So what's happening is that as a Forest Survey of India, when they give the statistics how the forest cover looks like, sometimes they actually underestimate this plantation as a kind of like, they actually include plantation as a forest, which is a big problem here. So plantation is not a forest. Plantation is a way of deforestation. And the problem that we actually find out in this study is much more grave. It's not just limited to deforestation, that we are losing habitat, but we are actually causing a disease outbreak in this region. And particularly when we all face COVID-19 in this last 2-3 years, and we know what how major that can turn the whole world into such a big problem in the whole world, right? It's a pandemic. Now this deforestation in Wana, we have found that it actually caused major disease outbreak, which is known as cane-osert forest disease, which is also known as KFD. It's a kind of like a infected tick that spread this disease. And also there are two more diseases called just dengue that we all familiar with, and also another one, leptospirosis. They are actually spreading those diseases because we are causing changing this forest into plantation, and that disease outbreak is happening more and more in this whole region, in the district and the surrounding region. So I'll kind of like stop here, and I'll kind of take more question, and thank you all. And so that's basically a few of the environmental problems that I think India is facing right now, that it's pretty evident the climate change signal and heat wave, the more extremes heat, and the last one is more like a man-made changes in the land use, land cover, and that has a more social implication, like and also the public health implication as well. So thank you, and I'll just stop here and open the floor for question.
Thank you, Dr. Debjani Ghatak. That was a very, very interesting presentation, and piece of useful information very much at this point of time. So I now request participants to raise their hands if they have any questions. I have a lot of questions with all the data that Dr. Debjani has shared. Okay, I think we have a question in the chat box. Okay, so Dr. Niti Alexander, posted a question. Thank you very much for your very interesting talk, Dr. Ghatak. She has two questions. One is, in the table about heat wave fatalities in 2015, Andhra Pradesh came highest, and regions that witness high temperatures annually, for example, Rajasthan, did not witness those numbers. Have the fatalities reduced in the subsequent years? And what role do you think has government intervention played in such disaster management scenarios?
Oh, yes. So for the heat wave of 2015, I was also expecting actually more death. Number of fatalities would be probably higher in Rajasthan, but I actually, like, when I looked at the data available from this government websites, that I found that Andhra Pradesh was really the highest, and that actually was consistent with my individual finding as well, because Andhra Pradesh was also on the kind of the center of the um, heat wave, which is the like the kind of the first wave. So as a result, and also another thing is that this is really a good question, because sometimes we think if a place is in general climatologically hot, we'll find higher number of fatalities from that place, but that generally does not happen. A place can be climatologically, a place can be hot like Rajasthan or Gujarat, right? Or even like in South India, we know the temperature goes up pretty high, but when this climate extremes, like this heat extremes happen, that actually it's different. This is like an anomaly from the normal. So for example, in Andhra Pradesh, the situation is it's a generally hot place, not as maybe hot as Rajasthan, but the anomaly is much higher. And when I'm saying the word anomaly, so how we calculate this is that we have a long-term baseline, like an average, let's say for 35-40 years. Now for a particular year, we calculate that how much more it's away from that baseline, right? So that means it's a positive anomaly. It means it's maybe 10 degrees Celsius up above the normal or average temperature for Andhra Pradesh, for example. So in that 2015 heat wave, actually, that's what happened. So that kind of the, I'm going to go back to the map to kind of explain this. So if you look at my map D, that very red area is basically the region where the temperature was anomalously very high for that time period, means May 21st to May 28th, and that actually corresponds to the number of fatalities. Now, what role, your next question is, what role do we think that government intervention played in such disaster management? And I feel like it's not just me. I think the government has a big responsibility, and they can reduce this disaster management. And particularly, and I have seen that you actually in the conference, you have a talk lined up on climate justice. So for example, I'm going to take this in a little bit bigger perspective, like not just a heat wave, all those natural disaster like heat wave, flood, or hurricane, cyclones, right? For all those things, I think we all know that the people who are economically like more poor, or they get affected more than, of course, economically they're doing well, they're not affected that much. So that's why I think government's role is more important to kind of do this management, so that we can reduce the impact on people. And I think my research also kind of shows that we can actually reduce this land surface atmosphere interaction, because we are actually more at a global scale, we are actually causing a lot of soil erosion. We are destroying our soils, we are changing our landscape, and that has a big implication how this whole surface interacts with atmosphere, and that changes the atmospheric processes, and that is a big trigger in this event. So there comes our role in managing our land surface, so that we can minimize this kind of events. Now I'm going to your second question, which says, Could you please elaborate further on the rise of disease in tropical areas such as Wanad, and how deforestation linked to it, and how do tropical areas such as Wanad differ from disease tropical areas in other parts of the globe? So basically for Wanad, what we have found is that there is a kind of a pathway, and it's very complicated. I'm giving like one example here. So when we're changing forest into plantation, and sometimes at the government level we say that we are not losing forest, we are just creating a different kind of forest through plantation. We actually change the whole species of plants that used to survive in the original forest, but they cannot survive in the plantation, for example, in teak or eucalyptus plantation. So what happens? What's the outcome? The outcome is the animals who used to live, or let's say their food or resources used to depend on those plant species, for example, monkey. Okay, and it may sound funny to you, but it is not. So monkeys used to live in a particular they don't have any more food in the forest, because those forests are plantation now. So those monkeys are coming out of the forest and coming into human settlement in search of food and their resources. Right now here comes human monkey interaction, and sometimes monkey actually carry those disease, like for example they are probably carrying those infected ticks. So this is a pathway that how plant changes of like deforestation basically create a pathway where the disease is transmitted from forest and coming into human settlement. And tropical regions are of course vulnerable to all this, because because it's just a kind of like a breeding site. It's kind of a breeding site for dengue, breeding site for a lot of those diseases. I don't know if I explained enough, but this is just few of the there could be many diseases are kind of falling into this category, which is actually known as emerging infectious diseases. A big group is called EIDs. And I kind of give just one example. It's like a tip of the iceberg, whatever I just said. And I hope I answered your question. If I missed something, please let me know. I also see hand from Dr.
Rajneesh Mishra.
Yes.
Rajneesh sir, you can ask your question. Okay, I think there is some.
I think
his
screen is
issue.
But I can
question
take
from
other.
Dr. Priyanka.
Okay.
Am I audible now?
Yes, sir. Just a second. The speaker is now checking Dr. Priyanka's question.
Please, go
I'm
ahead.
sorry.
Go ahead. No. I think my internet connection is a bit unstable. You carry on with that, and let me fix this. Yeah.
Sure, sir.
Are you going to read the question or?
Oh, Priyanka, could you please go ahead? I'm sorry, I lost the track. It's the question on the chat, right?
Yes, it's in the chat box.
Okay, if you can tell us about your data collection process a bit, that's question, right, Priyanka?
Yes, actually, I have been familiar with you for a long time. So I know that how we came, like I know our geography background, and from the same, background, we like moved ahead, and I kind of focused on human geography, you kind of focused on physical geography. And from there you became a climate scientist. So I would also like to know your journey a little bit as from a physical geographer, like, in a layman word, like, broad physical geographer to a specific, climate scientist. we have some students here in geography, and I think it will be very helpful for them to know your journey. And also, if you could let us know about the data, like I think you don't do field work, you have like more database kind of work, and what kind of climate data, how you collect it, the data collection process, because if you can talk about that little bit, it will help us to understand also. And
yeah, sure, Priyanka. So, yeah, first of all, like, I don't know if the audience know, but our history went back when we were in undergrad in students in Kolkata. So I have fond memories, and it's just like how our career took us apart, and as a result, I sometimes feel disconnected from my friends, and I really blame myself only for that, because life keep us so busy that we feel lost this connection. But I would like to, of course, share this journey, because this is so what happened is that when I came to US for my grad studies, I was not sure what kind of research I will do, and I was more inclined to research like urban heat island, where you see some interaction between physical science and its impact on more human environment. So it's not a completely physical geography, but it's like more like an interaction between physical and human geography. But that did not happen, and I just kind of took a lot of courses, and I and that time a lot of news came out about different Arctic climate changes. And also my advisor at that time was a professor there, so I took courses with him, and as a result I kind of like ended up doing research in more physical sciences. So the journey, I would say, was kind of very difficult, because I was not trained in a lot of things that you need the training to do this kind of work. So that's why I had to take a lot of different courses to learn those. And I'm actually honest, I'm still learning, and I'm still learning new things, and I still feel that I'm limited. And that's why I think it's more important that you do collaboration with other people who sometimes are good in something, and we help each other in growing and in learning. So basically that's pretty much what happened. And I had to I'm coming more to your question about the data part. So this is definitely not where we go to the field. We actually get most of the data from satellite. So for example, when I started working on Arctic climate change, lot of the satellite data were actually available, were becoming available. And I had committee members in my PhD thesis who are more kind of hands-on on, for example, a data on snow data sets, for example, who really put together like a snow data for the whole world. So they are very kind of a, they're very good at, about what good data is, and which data set that you should use. So Priyanka really asked an important question, and that I still, like, whenever I teach or I speak to my students, I always tell them that like, actually, particularly, and I want to give this example, like when I was working on this deforestation and disease outbreak, we actually were looking at some climate data, but we just had to give up because those data sets are not good. You cannot really rely on any data that you get or download from internet. So for that, you have to be super careful that, is your data good? Is your data really coming from reliable sources? And for that, those national agencies like National Snow and Ice Data Center, or NCDC National Climate Data Center, or for India, for example, Bhuvan has a great geoportal for land surface land cover maps, or IMD, Indian Meteorological Department, has a great data sets on Indian all those weather stations that India actually runs. So you actually have to go to those databases, the root databases. So do not, my message to the students are, like, do not just download any data and rely on it, because you may see some signal, you may find something, but that may not be reliable. So that is a huge time consuming part in any research, just to kind of find a good data, test the data. If the data set is good, then download them, make an archive for yourself, and then actually do more analysis and get results. So
thank you, Debjani. Thank you for explaining it in detail for the students also, and the importance of finding reliable data for our research. That's a big part, and that can make a lot of difference. Thank you for your answer.
Thank you, Priyanka.
Yeah, Dr. Rajneesh, sir, are you there?
Yes, I'm very well there.
Yes,
I'm still afraid of my unstable data, this one connection. That's why I kept my camera. I chose to keep my camera off for some time so that I can communicate what I want. First of all, Dr. Debjani, thank you so much for such a wonderful talk. We all have really liked it so much. Especially when you talked about how at on one hand, say, Himalayan region temperatures are rising, and at the same time we are finding more snow in Karakoram region. These kind of disparities or contradictions are visible across the world. Every time when we hear when winters come in northern part of India, they say, oh, this is the lowest temperature recorded in last 20 years, last 30 years, last 40 years, especially in the region of Punjab, UP, Delhi, and so on. Also, in the last couple of decades, we saw the news that in Middle Eastern countries, which is largely a desert and warm place, we saw snowfall happening in the area of, say, Saudi Arabia, Iran, and so on. How do we, as a layman, as a person who don't have much of geography background, how do we see all this? How these contradictions are happening, and what are the major things which are changing? If you can throw some light on that.
Yes, so particularly, I also saw that in the news, like in the desert region in the Middle East, they saw snowfall. And so what I will give you, maybe not answer to exactly what's happening in Middle East, but because I don't know, honestly, that probably needs a thorough research on that. But I can just shed some light on the same note. So what's happening is that when we are having this climate change, we are having basically the warming of this planet only does not mean warming the surface, right? That means warming our ocean. Now, ocean is a big heat sink, means when the water surface is warm, it is actually causing lot of evaporation, and lot of evaporation means we are adding lot of moisture, this water from the ocean surface to the atmosphere. So this is called triggering a water vapor feedback loop. Now this feedback, how does it work? That if you have more water vapor added into the atmosphere, that water vapor now is available to fall as precipitation somewhere. Now, if you have a storm coming, means not just it could be monsoon, or it could be just any storm that brings precipitation at any place. It could be Middle East, it could be Russia, it could be Great Lakes region of the United States. You actually may have more moisture available for that storm that you did not have before. So one thing is that your precipitation is becoming more intense. Now, also when you're having this precipitation, if your atmospheric temperature is just perfect for turning that rain into snow, you will actually have more snow. So that's what is happening actually over a part of Eurasia, where we are actually seeing some more snow even in under a warming climate, where other places are losing snow. So what we are going to, and a lot of scientists are saying the same thing, so what's going to happen is that this is called triggering or enhancing your water vapor feedback loop, and as a result we just have more water vapor in the atmosphere, as kind of like a more source of, you can say, more source of precipitation or snow or rain. Now, I also want to point out this, that does not mean that everywhere only will get more rain. That's not going to happen. Some places will be more rainier, some places will be more drier. So these extremes of having more flood or more drought will be enhanced or intensified, and that's really what the climate change signal is going to happen. So some place which is like a drought prone, and I'm giving you an example, let's say southwestern part of the United States is actually a desert in general. So they are anyway drought prone. So that region will face more drought. If some place is already wet, probably that place will be wetter. So the wet can be wetter and the dry will be more drier, something like that. I don't know if that, does it make sense, Dr. Mishra?
Definitely, Dr. Debjani. It was a very,
Okay.
I mean, it is just out of curiosity, just a related query. Again, it is more like a curious person is asking an expert. You have mentioned about IPCC, and I know IPCC has came with a very recent report on climate change, which obviously it's huge one, and people whose research area is not related to climate change may not be able to go through it thoroughly. Would you mind giving some takeaways, important takeaways from that IPCC report, especially related to your area of research, deforestation, or the heat waves and other things?
Yeah, so I think the few things about the IPCC, as here, you guys also do a lot of interdisciplinary research. So IPCC actually has, even before giving you maybe one or two kind of take home message from my field, I want to also point out something, that IPCC has a big kind of a human, not just a human geography, more like a social science side of the IPCC report, because a lot of scientists who are like a social scientists who also does a lot of socioeconomic kind of research, they have a big representation in IPCC report. So I think there is a potential for Indian scientists to contribute to that, and contribution means, of course, like doing more research and publishing, and that's how you can actually contribute to the report. And of course they need more representation, for example, what's going on from more like Indian perspective. So I think there is a big room for social scientists there to work on IPCC. So for my thing, what I can say is that what I have found from published literatures, and a little bit of my work, that, for example, one big take-home message is that the Arctic sea ice will be seeing actually ice-free Arctic in summer. And though we don't know exactly whether this is going to happen in 2050 or 2060, but the way that we are warming our planet, we are changing, we are emitting greenhouse gases. If that pathway continues, that we will see that there will be no more ice in summer over the Arctic. So that's for sure. Another thing that is also kind of take home message from IPCC projection is that of course, we're gonna lose, a lot of glaciers, like we're losing over Himalayas and many other places. So we're gonna lose the glacier. The permafrost will be melting, and that's a big, like um, another area that a lot of people do not know is in the very high latitude region, like places like Alaska, Canada, Russia, northern part of the Europe. There is the ground remains frozen, and that's called permafrost, which is permanently frozen ground. As we are actually causing this global warming, that land will be also melting, and that means there's a huge storage of basically it's going to be releasing a lot of carbon dioxide and methane from that soil to the atmosphere. So that will also trigger our global warming. So that's another, I think, big kind of a take-home message from Ipcc. But yeah, so it's a pretty lot, and honestly, they actually have published. They kind of at a certain interval they release their report, and they also, another thing they do is that they publish those data sets available to the scientists, where scientists can actually use them. So that's something that I'm also looking forward to use.
Thank you so much, Dr. Debjani, for patiently responding to these questions. Thank you so much.
Oh, no problem. My pleasure.
Over
Thank
to
you,
you, Dr. Hima.
Yeah, thank you, Dr.
Thank you, everybody, and thank you, Priyanka and Dr. Tanya Chakraborty, for communicating and so patiently. I really apologize. Sometimes I kind of like fail to reply instantly because I was teaching and it's just a little overwhelming. Sometimes I really apologize if I delayed the communication. But thank you, Priyanka. Good to see you after a long time.
Thank you very much, Dr. Ghatak, for being here today with us. We are very grateful that you were able to make time and come here and deliver the talk. Thank you.
Thank you. Bye-bye.
Dr. Priyanka, you are on mute.
Debjani, one of the participants, they have asked your, recording. So are you giving permission to upload it on YouTube, like on VIT channel?
Yeah, that's
okay. Thank you.
Okay, now the stage is over to you, Dr. Priyanka and Dr. Tanya.
Oh, okay. Okay. So obviously, thanks once again to Dr. Ghatak for being here today. And thank you, Dr. Hima Bindu, for hosting the session so wonderfully. We are very grateful to both of you. Due to some unavoidable circumstances, our next speaker, Mr. Prasad Babu, is not available today. He will not be joining us today. So we will be taking a break now. Till 11 o'clock, and from 11 o'clock our next session, plenary session 3, will be starting. Dr. Rashida Parveen will be chairing the session. I request all the participants and the speakers and our session chair to join us by 10:55 so that we can start our session from 11 a.m. And Dr. Priyanka, I will request you not to end the session. Not to end the meeting, just so that the participants and the audience can again join back using the same link. Okay?
Yes, I am not ending it, just keeping it on.
Yes, just keep it on. Okay. Thank you very much. Thank you to all. And hopefully we will all see each other again from 11 o'clock.
Thank you.